Hi, I'm Elizabeth Bagley, and I am the director of Drawdown Learn at Project Drawdown. Now, you'll hear a lot more about Project Drawdown today from Dr. Foley, but Project Drawdown is the world's leading resource on climate solutions. So today you're going to hear not a whole lot about the climate problems, because what we really focus on is shifting that conversation, right? Moving from talking about climate problems to talking about the solutions to climate change. And spoiler alert, there are a lot of them. And John will talk a lot about the solutions that we have in hand today to combat the climate crisis and really create the future that all of us want and deserve. So I'm really grateful you're here today. One more plug I'm going to make is please sign up for our newsletter. It's on our website. I think some of you might have signed up for the newsletter when you registered. Thank you so much. That's our main kind of official way of communicating with people. We also have a number of social media channels. You can find us on Twitter and Facebook, and soon we'll have a more of a presence on Instagram. And we have a lot of really, really exciting things coming down the pipeline. So that's why I'm plugging the newsletter and our social channels. We've got a lot that we're excited to share with you. One thing that I can give you a quick sneak peek about is a Climate Solutions 101 series of videos focused on the science behind climate solutions. So if you love what John's going to do today, we're actually going to have a 6-unit series coming out in early 2021 that is also accompanied by 10 conversations with climate experts from around the world. So it's a really kind of one-of-a-kind resource that we're going to have available for free for everyone. Again, that'll be early 2021. The best way to find out about when that drops is to join our newsletter or sign up on social media. I feel like I should say, click here to subscribe, like I'm a YouTube celebrity, but we don't have that yet. So all that said, thank you everybody for coming. A couple quick house rules. Y'all are muted and we can't see you, unfortunately. You're just going to be able to see John and his slides. Please put any questions that you have in the Q&A. I'm going to be watching the Q&A, and then at the end of the talk, that's where I'm going to pull questions from, and that's where we'll have that discussion. So please put any questions there. And without further ado, I would love to introduce the Executive Director of Project Drawdown, Dr. Jonathan Foley. Take it away, John.
Well, thanks, Elizabeth, and thanks for. It's really inspiring to see folks from like all over the world show up. You know, you throw something out on the web and say, "Hey, we're going to have this webinar," and I usually expect that like no one will be here, but there's hundreds of people from all over the world showing up out of the blue. So that's really fantastic. And thank you for some of you noticed. Getting a few nice comments here. I did have COVID for about a month and felt pretty awful, but feeling better now, obviously, and back to work. So thanks for the kind words about that, and hope you're all doing well and staying safe. Super important these days. So we're going to talk about climate solutions, and I'm going to give a little bit of a presentation for about 45 so minutes. And then after that, we're going to have kind of more of a discussion and kind of conversation in the Q&A box that Elizabeth will moderate. And Elizabeth is fantastic. So Dr. Bagley, Elizabeth, as you saw earlier, she is just a really world leader in sustainability education, is going to be leading our Drawdown Learn initiative into the future and growing it tremendously. So this is just the beginning of some work we're doing. But Dr. Bagley is doing amazing work in all these respects, and I'm just so pleased to work with her on this kind of effort. So today we're going to talk about how we could achieve drawdown. How do we get to a hopeful and science-based way to solve the climate crisis? And before we start, though, just to remind folks, if you want to learn more about what we're talking about today, you can go to us at drawdown.org. There's a lot of resources there to learn from and share, and they're all free, and that's all great. You can follow our organization on social media, as well as sign up for our newsletter at drawdown.org. But you can also follow us on places like Twitter and Facebook and soon Instagram at Project Drawdown. You can also follow me around if you want to on Twitter and stuff like that. And the only handle left on the internet that wasn't already used was Global Eco Guy. I was found, I guess, so that's me. But one of the things that's a really great resource is some of you will know the Drawdown book that came out about 3 or 4 years ago. which is a wonderful, that's kind of how we got started. That was our first kind of stab at all this kind of work, and it was great. But we've actually updated the whole bloody thing and taken it to a new level in something called the Drawdown Review, which is freely available as a PDF for free, and you can share it with anybody you like on our website. So if you don't want to buy a book, you can go to online and download this thing, and it's the latest, greatest work from just a few months ago. Plus, there's a new report just about agriculture and climate change, which talks a lot about regenerative agriculture, which I know a lot of folks are interested in, but also other solutions to climate change from the food and agriculture and land use sector. That's also available for free. So check us out. We're trying to help you and be a resource. Okay, let's start. As Elizabeth said, we're talking about solutions to the future of our planet, to making it better, to avoiding catastrophic climate change. But as we think about the future, sometimes it's helpful to think about the past and how we got here and how we got to this problem we have today. Well, our ancient ancestors who eventually evolved into Homo sapiens started to recognizably diverge from other animals and kind of walk this planet maybe 6 million years ago. So something like human beings have been walking this planet for 6 million years. And we've always affected the environment around us. We hunted, we gathered, we made little communities, we did all sorts of things. But starting about 10,000 years ago, we started building cities, we invented agriculture, we started doing more and more and more, and our impact grew. But it's really the last half century where we literally kind of exploded into being a planetary force. And that happened for a number of reasons, but several of them are shown here. First, we grew in numbers tremendously. We're now about 7.5 billion people. At the beginning of the century, is closer to 1.5. We also became an urban species for the first time in human history. Most of humanity in the past was rural and lived on farms or out in the countryside. Today, most of us live in cities. And then we built a global economy with global trade, globalization, information technologies, and unbelievable things that have accelerated the economic development of the last half century beyond anything ever seen in history. And all of that wrapped together during the last, let's say, 50 years or so has just been a juggernaut of change. We doubled the population of our planet. We grew the economy 5 to 6-fold, even adjusting for inflation. We had tripled our demand for food. We doubled our demand for water, and we tripled our use of fossil fuels. And just in those 50 years, we changed more, and we changed the world more than we did in the previous 6 million combined. So we're living in a kind of inflection point in human history. Like everything's changing. Even the way we change is changing. And our actions are no longer just affecting and disrupting the local environment right where we live, but it's disrupting an entire planet into something we will not recognize if we keep going. Some of those changes are obvious. They're right in front of us, so you don't have to argue about them. You can see them right in front of you. Is, for example, clearing of rainforest. Here in the 1970s, we see the very beginning of plantations and pastures and things invading this little part of the Amazon in Bolivia. But we go back about 25 years later, and it's just been decimated almost entirely to grow soybeans as animal feed to be shipped to China to help satisfy increasing pork production as Chinese economy and meat consumption increase dramatically. So globalization, our need for meat, animal feed, palm oil, timber, things like this, has already cleared about 30% of Earth's tropical forest. And most of that happened recently. We've also managed to change the water cycle of this planet, not just a little bit, but a lot. And here's a really startling example. One of the largest geographic features of our planet that you could see from the moon would have been the Aral Sea, one of the largest inland seas on the planet. But the Soviet Union, where this is in the former Soviet Union in Central Asia, diverted the water supply to the Aral Sea, 2 large rivers, and then sent them into Central Asia to be irrigating cotton fields in Kazakhstan. And this is what happened. The Aral Sea has now basically disappeared. We've erased one of Earth's geographic features just to grow a little cotton in the desert. And whether it's here in the Aral Sea or maybe Lake Chad in Africa or our Agawala Aquifer in the United States and the Colorado River, we have just collapsed water resources all across the world. many, many times by simply overusing the water that should be there provided by nature. So that's why I'm showing you is that we started to change the nature of our planet globally in terms of things that are obvious, like what land looks like, what water looks like. But we've also started to change the sky. And this is the hard one. This one took a little while for people to kind of figure out, because by its very nature, changing the atmosphere with greenhouse gases is invisible. The greenhouse gases that we're adding to the atmosphere, and we'll talk a lot about, are warming the planet, but they're invisible to our eyes and to the sun. Sun's radiation, which we see in, goes right through them like it's transparent, warming the Earth's surface. But Earth radiates back that energy to outer space in the infrared wavelengths that you and I can't see. And that's where CO2, methane, and other gases trap some of that radiation, that heat, and re-radiate it back to the Earth's surface. And we can't see it. It's a miracle we even noticed it was happening at first, but it is. And in fact, we've been increasing the level of these gases beyond anything seen in the last 3 to 5 million years through our activities. One of those gases, not the only one, by the way, but one of those important gases is carbon dioxide, one of the principal culprits of climate change. And it's increased by about 50%, not just a little. We added like a whole 50% more than the planet's seen in 5 million years. And we're not even done yet. So we started doing that in the mid-19th century, and today it's just higher than it's ever been, and we continue to set records each and every year so far. And we know the physics of this, that if you trap heat in a planet, it's going to warm. This is not rocket science. This is actually really basic stuff. So as CO2 and other gases increased, so did the temperature of the planet. The planet has already warmed about 1 degree Celsius, maybe closer to 1.1 so far. And that's how the warming has unfolded over the same period of time. There are a lot of things affecting Earth's climate here and there over a few years, maybe a decade. It has lots of other little things going on. But the overall pattern of more greenhouse gases and a warmer planet is very, very clear. So as I was saying, CO2 increases over the last 50 years and have since the 1850s have started to warm the planet. That we've seen a 50% increase in CO2 levels and about a 1 degree increase in global temperatures. And what I was saying before we had our last little glitch was that this was actually discovered back in the 1850s. We used to credit this to a guy named John Tyndall in the UK, who published something about this in the 1860s, but actually it was an American woman named Eunice Foote, F-O-O-T-E, who actually first published this in 1856, about 4 years before Tyndall. And most people didn't know that. I didn't know that. And I've worked in climate change for 30 years. It was kind of recently uncovered. And I just wanted to make a note that, hey, she's been kind of not given proper credit for almost 160 years. Maybe it's time we give her a tip of the hat and say, thank you for helping us understand climate change. But also the important note is this is something we figured out in the middle of the 1800s. And, so this is not new science. We know that CO2 increases and other greenhouse gases warm the planet. Debating that is just pointless. It'd be like debating gravity. So instead of talking about the climate problem, which is an incredible challenge, if climate change continues to happen in an uncontrolled way into the future, it could cause massive disruptions to how we grow our food, where we get our water, our economy, our health, our security, other things we care about like equity and justice. They're all going to be challenged by a climate that'll be careening out of control. We really don't want that. So we need to stop this. And I want to say right now that climate change is not hopeless. We can still build the future we want. We can avoid the worst of climate change if we start to act now and really focus on key solutions. And that's what I want to talk about, because addressing climate change is going to be crucial to getting to a better future. And that's what we're here to help out with. Project Drawdown, we're a leading resource around climate solutions. And I want to tell you why we chose the name Drawdown. Drawdown does not refer to removing carbon out of the atmosphere. Some people think we're like about carbon removal or just planting trees and stuff like that. No, it's actually bigger than that. Drawdown is not removing carbon from the air. It's a place in time. If greenhouse gases have risen this much already, we might just continue on this path, kind of a business as usual path into the future where it just gets worse and worse over time. That would be terrible. We don't want that. So instead, just like we are trying to do with a pandemic, let's bend the curve away from bad stuff towards something better. Drawdown actually refers to the moment we start to do that. This point, this little blue dot, that's when we hit drawdown. This is when we start to slow down the rise of greenhouse gases, eventually hitting a peak and then bringing them back down. And that's the moment we stop future warming from happening across the planet. So the moment of drawdown is the point in the future when greenhouse gases stop rising and they start to climb down. And that's when we stop climate change. And that's our mission. We want to help the world get there as quickly and as safely and equitably as possible. So that's what we're going to talk about today. How do we get to drawdown safely and speedily and equitably? Well, to do that, we've got to understand this problem a little bit more. A lot of people think that climate change is just caused by CO2 rising in the atmosphere. No. There's many other gases as well. And we've got to look at the entire chessboard, the whole thing, not just the carbon dioxide part. CO2 is rising, methane is rising, nitrous oxide is rising, and a whole bunch of other gases, including fluorinated gases that we'll talk about later. These all contribute to climate change in different ways. CO2, methane, they all have different abilities to trap heat, and they all last in the atmosphere different lengths of time. So what we do to kind of play this all together to make them kind of an apple-to-apple comparison was we look at today's emissions and ask how much warming would that cause over the next 100 years? What's called the global warming potential. Like how much warming would this cause over the next century? When we do that, we can kind of compare all these different gases and where they come from. And we recognize that, yep, one of the biggest reasons we have climate change is CO2 coming from burning fossil fuels. But if I gave you a test and said, what causes climate change? And you only put down CO2 from fossil fuels, you'd get a D- in my class because it's only 62% of the answer. You left about 40% of it out because it turns out that CO2 also comes from cement and industrial chemicals that outgas CO2 to the atmosphere, not by burning a fossil fuel, but by chemistry. Then we have CO2 emitted from deforestation and land use, but especially burning of forest. When you burn a tree, it's like burning coal. They're both made out of carbon, and that releases CO2 as well. And then we've got the other gases like methane, which warms the planet a lot during the first 10 to 20 years it's emitted, and then it goes away rather quickly after that. But it's still really important because we emit it year after year after year. And about 2/3 of our methane comes from agriculture, primarily from animal agriculture, beef, dairy operations, things like that, a little bit from rice fields too. The other third comes from industry, especially fracking for natural gas pipeline, and what we call fugitive emissions, kind of the leaks of natural gas into the atmosphere. Methane and natural gas are the same thing, by the way. When we burn natural gas, that's actually methane, which is a potent greenhouse gas. We also have another gas called nitrous oxide, or N2O, not to be confused with NOx, which is a whole different animal. N2O, though, mostly comes from agriculture, from using too much fertilizer. It's made when we apply too much fertilizer or manure on a field when it's kind of cold and wet sometimes. The nitrogen in the fertilizer mixes with air and water and releases N2O into the atmosphere. It is a really potent greenhouse gas. Then we've got this other class of gases called fluorinated gases, or F gases. Those include hundreds of individual chemicals, but the biggest family of which used to be chlorofluorocarbons, or CFCs. Some of you will recognize that as like, hey, wasn't that stuff involved with hurting the ozone layer back in the 70s? Didn't we phase that out? Yep, we mainly did. There's still some lurking around in black markets around the world, but we got rid of most of them. But we replaced them with hydrofluorocarbons, or HFCs, which are ozone friendly. They don't hurt the ozone layer, but they're not climate friendly. They trap a lot of heat. And it turns out that's only 2% of the atmosphere's warming today. But as people around the world get richer, and about 1 billion or 2 billion people are about to buy an air conditioner for the first time, which is where these gases are used the most, or in refrigerators and freezers, these are used as coolants in compressors. If we do that and we don't manage those gases well, a lot of them will leak out, and we could see that 2% quadruple in the next decades or two. So that's going to be very, very important as well. So just to remind you, greenhouse gases are more than CO2, and it's way more than just energy. Again, look at the whole board if you want to win this game. We also have to recognize the atmosphere is not a static thing. We're not the only thing changing the atmosphere or affecting the atmosphere. What we do is we put greenhouse gases into the air. That's us on the left-hand side. And instead of the chemistry of those emissions, I put down kind of the economics now, this time, of like what human activity is contributing these gases to the atmosphere. We'll go over this in a minute, but you see things like electricity and industry and food and transportation. So the left-hand side of the picture, that's us. We're putting junk in the sky and causing climate change. But nature's there too. And nature's removing a little bit of our pollution, what we call sinks, or the things that remove greenhouse gases, are happening at the same time. It turns out land and oceans are both absorbing some of the excess carbon dioxide part of our emissions. This is nature, though. This is not us at all. We haven't even budged those numbers yet. Those things are caused by mainly healthy forest still around the planet doing some more photosynthesis, and oceans absorbing CO2. Maybe we need to pay attention to both of these things, reducing our pollution and helping nature do some removal. But what happens is we put in like 100 units of greenhouse gases. Nature takes out about 41 of them, thank goodness, leaving behind about 59% in the atmosphere each year. And that builds up year over year over year, accumulating in the atmosphere, causing more climate change. So if you really want to solve climate change, it's smart to look at both sides of this. What can we do, and what can we help nature do? So that's going to be an important part of our solutions as we move forward. Oops, here we go. So to achieve drawdown, we need to do a couple of things. We need to look at the left-hand side of the equation and the right-hand side. On the left-hand side, where we're acting as emitters of pollution into the atmosphere, we need to bring those to zero, not net zero, zero, zero. They have to go to absolute zero in the next couple of decades. Otherwise, we will not be able to stop climate change. And so every opportunity we can to diminish and zero out those emissions is what we must do. And at the same time, we can help nature continue to remove CO2, at least that part of our greenhouse gases, out of the atmosphere and bury them into trees and soils and into the ocean. And if we do that, we remove the sources and we keep the sinks, then we hit drawdown, we bend the curve, and we start removing greenhouse gases from the atmosphere. A little metaphor I use a lot is, imagine the atmosphere is like a bathtub, and we fill the bathtub with a faucet. That's our emissions, that's pollution. We're the faucet. Nature is the drain of the bathtub that can remove some of that water or greenhouse gases. So we need to do both. We have to turn off the faucet, and we need to keep the drain open. If your bathtub's overflowing, destroying your house, the first thing you do is turn off the faucet, then you open the drain, and then you look for some mops. So that's where we are today. So the solutions to climate change must also obey these kind of physical laws: reduce sources, enhance sinks across multiple dimensions. So let's walk through a few of them. First of all, we have to reduce those sources, stop pollution before it gets into the sky, before it does any harm. That's job number one, bring emissions to zero. And to do that, we've got to focus on these arrows. These are the things we do that contribute to climate change as kind of human activities around the globe. Let's look at them individually. Again, we're looking at what we do today and how much it'll affect the planet for the next century. These are global numbers. If you looked at an individual country like Germany or Portugal or Ireland or whatever, they'd all be a little different. They're very different within the United States even. But this is the global number, and the atmosphere doesn't care about boundaries. And so we need to look at this stuff too. So it turns out that producing electricity causes about a quarter of future climate change. That's us burning coal and natural gas to make electricity. That's really important. But a lot of people think it's much bigger than that. And it's about a quarter. Another quarter of climate change is caused by our food system. Making food, clearing land, and farming produces another roughly quarter of climate changes equal to electricity. And yet you don't hear nearly the same amount about that compared to electricity generation. They're both about the same. And together, making electricity and making food is half of the climate problem we're causing. That's kind of incredible. Industry is causing about 20% of climate change. This is making everything, whether it's cement, steel, plastics, dealing with waste, everything that we buy, all the stuff made in industry, that's about 20%. Then we have transportation, moving stuff around, including us, is about 14% of climate change. And then we have buildings. Now, buildings are a little confusing. Buildings emit in two ways. One is right inside the building. That's what I'm showing here. That's from the building itself, from the hot water heater, the furnace, boilers, the leaking air conditioners, the things within the building envelope on site. Buildings, of course, are what we are largely responsible for the consumption of electricity. So it's part of the orange sector as well, is used in buildings. And buildings are made out of stuff developed in industry. But the way these accounting rules are done, you track the emissions from where they were emitted. So when you use electricity, the emissions are counted at the power plant, not in your building. That's how these rules work. And the cement that makes your building was counted in the industry where the cement was made, not at the building site. So that's a little confusion sometimes, but buildings are really important both directly and indirectly across the climate space. Then we've got everything else. The remaining 10% is everything else we do on the planet. A lot of that is in the energy industry itself. We're refining crude oil and turning it into useful petroleum products, for example, and things like gasoline, but also fracking, fugitive emissions, leaking pipes, all that stuff. That's a big part of that 10%. But look at the other 90. Isn't this amazing? Only 5 things cause 90% of our climate problem: electricity, food, industry, transportation, and buildings. If we tackle those 5 things, we get 90% of the problem. And the other 10% we can focus on too. So let's walk through these a little bit. Electricity, 25% of the problem. Okay. Producing electricity, that is burning coal and natural gas, causes this climate change. So if we make electricity in different ways that don't burn coal and natural gas, this number can go away. We can also, though, look at the demand for electricity. How much electricity do we even need through energy efficiency? Can we reduce the demand for electricity even if it's made with coal or natural gas? Can we do that in buildings and industry and other places? You bet we can. So in Drawdown, what we do is we analyze hundreds of different possible solutions to climate change, looking across all the published literature, every piece of data we can find on the planet, to get the best possible picture on climate solutions. So for electricity solutions, we can do 2 big areas of solutions. One is, let's do more efficiency, reduce the demand for electricity overall, whether it's produced by coal, natural gas, or renewables. Then the other thing we can, and a lot of these are going to be in buildings, of course. And so that's enhancing efficiency. Energy efficiency is crucial, and it can happen right now and work perfectly. And then we can also simultaneously change the way we're making the electricity we still need by shifting it to renewables like solar, wind, hydro, and so on. That's going to be really, really important as well. So to summarize what we can do in the electricity sector, we draw pictures like this. These little circles represent climate solutions. Each circle is a single solution, and the size of the circle, its area, is proportional to how big the solution is for fighting climate change. So the bigger the circle, the bigger the impact it can have. Some solutions actually have 2 circles, like an inner one and an outer one. That represents a range of what we think could be plausible, sort of a high and low limit, let's say. So energy efficiency matters a lot on the right-hand side, and shifting the way we make electricity is important too. And this is really, really great. And by putting all these together, we have some great solutions in the electricity sector. Then we go to food, agriculture, and land use, kind of the act of growing food on this planet. Well, that's another big contributor to climate change, about 24%, just about the same as electricity. That area is kind of confusing for some people, though, because there's so many weird things about our food system that need fixing. But in terms of climate change, the big culprits are really three big areas. First, deforestation. Burning down a rainforest, for example, to grow more cattle or more animal feed or more oil palm, that's an immediate, obvious source of greenhouse gases right into the atmosphere. Boom, you just put a whole bunch of CO2 in the air by burning down a forest. Second is methane from animals and rice fields. Despite some claims people are trying to make, this is a really crucial part of climate change, is methane emissions, whether from animals or from industry. And this is contributing to climate change too. Methane levels on this planet are higher than they've been in millions of years as well, and we did that. So we'll have to look at the emissions of methane from especially animals, but a little bit from rice. I'm going to foreshadow there may be ways of raising animals that can still have methane emissions, but maybe we can counteract that by putting carbon back in the soil a little bit. We'll talk about that, and that's called regenerative agriculture. But here we're looking at the sources and how we have to cut those down. The third area after deforestation and animals is fertilizer. And that's through nitrous oxide emissions, because we use too much fertilizer and too much manure on a lot of fields around the world, way too much. It causes climate change gases going into the atmosphere and water pollution going into our rivers and ultimately into our oceans, causing dead zones at the mouth of most major rivers on the planet today. And that's not making fertilizer. That's actually relatively small. It's the fertilizer itself is the bigger problem than the energy it took to make it. So the biggest changes we got to address are stopping deforestation, limiting methane emissions from animals and rice fields, and stop using so much bloody fertilizer. That's going to be the three biggest levers. Everything else in the food system is the remaining 5%. Things like food miles actually don't really show up here. Turns out the miles food travels isn't that important. It's the way it travels, whether it's by ship or by rail or big trucks versus little trucks. The biggest emitter of transportation and food, the food miles problem, is actually you and me driving to a store, bringing back one bag of groceries in a sport utility vehicle or something. It isn't people shipping food to the store. It's us getting it from the store. But even that's pretty small. So don't worry about that from a climate perspective. Local food is great for many, many things, but it's not so much a big climate problem. So what we look at for food and agriculture solutions is kind of similar to what we did in electricity. If we don't need as much food, we automatically reduce emissions. And so the way we think about that is, it turns out by addressing food waste and mixing up the diets we eat around the world, we can have a huge immediate impact on greenhouse gases, but also land and water and biodiversity and so much else around the world, including food security for everyone. When food waste around the world is 40% of the food we grow is never eaten. Globally, 40%. It's insanely wasteful. We can do something about that. So that means 40% of the food that's not eaten. If we can solve that, that's 40% of the greenhouse gases. That's 40% of our forest and lands and water, and all of that stuff can be tackled right there with one area. Also, changing the mix of our diets to have more plant-rich diets, to have more plant-based proteins and other things instead of animal products all the time. And in a lot of countries, this would be good for our health as well. We're not saying everybody has to become vegan for climate change. No, that probably won't happen anyway, whether we like it or not. We're saying, can we cut down on meat consumption and substitute more plants for that, recognizing some people will still eat meat and dairy products, of course. So we're just talking about more plants, not getting rid of the meat, just a little less. Let's change the mix. Those are big solutions. Then we can protect ecosystems, especially forest, from being cleared in the first place. If deforestation is a big problem, stop deforestation. Just say, no, don't go there, don't do this. So protecting ecosystems, especially forest, and especially forests that are on top of peatlands and wetlands, especially like those in Indonesia that are being cleared for palm oil, because you're burning the trees and you're burning the peat in the kind of peatland soils below. And that's a kind of a double whammy. You don't want that. Then we could farm better on the farms we already have by using less fertilizer. Boom, right there, that's a big thing. And also other good farming practices that we sometimes call conservation farming, conservation agriculture, and regenerative farming, whether that's crops or animals or lots of things, as well as managing nutrients, water, and other things better, plus rice. Rice needs a little bit more attention because of its methane emissions. And there are ways we can fix that too. And if we look at all these solutions together by reducing the kind of waste and demand side part of the food problem, the food efficiency problem, just like electricity and energy efficiency, reducing food waste is by far the biggest solution in agriculture, followed by changing our diets, followed by protecting ecosystems, and rounded out by farming better on the lands we still need. But if we stop needing so much land and we stop clearing so much land and then farm better on what we need left, this is a good picture. All of these need to work together. I'll go more quickly through the other areas, but I think this pattern is something you'll see again and again, like in industry, where we make lots of things like metals, especially steel. That's a big contributor to climate change. Cement is a big contributor to climate change, just the chemistry of cement. By the way, if cement were a country, it'd be the third or fourth largest emitter of CO2 on the planet after China, the US, and the EU, basically. That's incredible. Chemicals, including plastics. Plastics is about 1% of climate change, really important, but much more important as a plastic pollution problem. So here's where maybe you can solve two problems at the same time. And then managing all the waste on the planet, like the landfills and all the stuff we throw away and have to do that. That's like 3% of the problem. That's a big deal too. The solutions that we've started to explore are how we can improve materials like cements and plastics, how we can use waste better. These refrigerants I mentioned before turn out to be really crucial, either using alternatives or managing them better, not let them leak into the atmosphere so much. Those are all crucial in the industry sector. We're now working on a whole bunch of industry solutions that haven't been analyzed yet, like different kinds of steel and building materials and things like that as well. A lot more work to be done there. Transportation, that's one we all know about because we all move around. Transportation is about 14% of what causes climate change today globally. And it's mostly roads. 10% of that is from roads. That is like cars, trucks, things like this. All the world's aviation and flying, including military and commercial air traffic, is 1.8% of what causes climate change. You hear some people try to fudge that number up to like 6% by multiplying by what they call a radiative forcing factor. You can't do that. That's comparing apples to oranges and kiwis and grapefruits. Because yes, flying emits about 1.8% of our greenhouse gases, causing long-term climate change. They also have a local immediate effect on the air around you by forming these contrails in the atmosphere. Those sometimes warm the local areas a little bit for a very short amount of time, and that can be important too. But so do ships. So does burning diesel fuel, so does deforestation and biomass burning, so do urban heat islands, so does everything else in this pie chart has other effects on the atmosphere. So you can't just look at flying that way and nothing else. It's not a fair comparison. But flying is really important because that about 2% of emissions is caused by a very small number of us who fly a lot. So I think that deserves a lot of special attention. Everything else like ships and trains and all that are about 2% too. But again, we can look at how we do things and from different demands and different directions. For example, shifting to alternatives that don't require fuel at all, like electric bikes, bicycle infrastructure, carpooling, walking, telepresence. We didn't have to fly together to get 300 people to see this seminar. We can all do it from our homes. That's fantastic. So alternative transportation is a big cluster of solutions. Then we can make our current transportation infrastructure more efficient. Still using petroleum to move around, unfortunately, but hybrid cars, efficient planes, efficient trucks, efficient ships, lots of room there still. And then, of course, electrifying everything, especially starting with cars and trains. For those Americans in the audience, our train system is a nightmare. Outside from Boston to Washington, D.C., actually taking Amtrak in the United States is more polluting than flying is. because they're using dirty diesel engines. I'm hoping President Biden will change all that. He's a huge fan of our train system, but we can make that overnight far more efficient by having much more modern electric trains, which is what we have in the Northeast and what they have in Europe and China, Japan, and a lot of other places. Lots of opportunities there. Buildings I mentioned before too. Buildings emit about 6% of greenhouse gases directly from buildings, not counting that electricity and building materials, which are accounted for elsewhere. But buildings themselves, especially residential buildings, 2-to-1 to commercial, are big culprits in this spectrum too. So here we can see, again, energy efficiency is really important, and changing the mix of energy within our buildings and living spaces as well is crucial, crucial, crucial. So those are the sources. You can see in those 5 big areas: electricity, food, industry, transportation, and buildings. Not one of them will solve climate change alone, but if we reduce emissions through efficiency measures and changing the way we do things in all those areas, we have ample solutions, hundreds of them really, to address climate change a little bit at a time. One of the things I really want to stress here, by the way, is our solutions tend to be like maybe tackling 1, 2, maybe up to 5% of climate change through individual solutions. And we need about 100 of them to add up to the whole pattern. There are no silver bullets to climate change. We need to do a little bit of everything. Efficiency everywhere we can, changing from high greenhouse gas to low or zero greenhouse gas ways of making what we need and using stuff. Absolutely crucial. So if anybody tells you they have the solution to climate change, it's not true. We all need hundreds of them to get where we need to go, because it's a much bigger playing field than you might think. So then let's go to the second area of solutions, where nature plays a role by removing part of our greenhouse gases. Now, nature does this by absorbing CO2 into land and into the oceans. It can't do anything about nitrous oxide or fluorinated gases, and it doesn't do much on methane. So already these sinks are limited. They only act on one of our greenhouse gases, not all of them. And these are nature-based. This is what nature has been doing for free for a long time and not charging us at all. So on land, mainly it's photosynthesis of natural forest, building up the trees, what we call biomass, basically wood, and building up the soils and making them more filled with carbon or organic matter, humus and other organic matters in the soil. That's really crucial. And the way we're doing that is basically in 3 areas. First, if we protect nature that's already there, that's job number 1. Protect and restore nature's big forests, especially tropical forest and temperate forest. That's in the middle. Then we can put into play all of the farmland on the planet. Right now, almost all the farms on the planet, ranches and croplands basically, and pastures, they're emitting CO2 and other greenhouse gases, especially methane, into the atmosphere. But what if we flipped it? And we started what's often called regenerative agriculture on crops, on grazing lands with trees, and what we call agroforestry and silvopasture. There are ways by kind of bringing that carbon home out of the atmosphere, back into the soil, back into trees, back into perennial grasses, that can actually become a carbon sink. And because agricultural land covers about 40% of the Earth's surface of land, or land surface, that's a big variable here that we could do a lot right there. There are limits to how much we can do there, and it's not just with the animals. We can do it on crops, we can do it with trees, we can do all sorts of good stuff here, and it's very promising. Third is we can go back to degraded lands, lands we did use for agriculture in the past, but we beat them up so much we're not even farming them today. They're just abandoned pretty much. What if we could bring them back? What if we could restore those systems to health? Whether we farm them or not, can we bring them back to nature or bring them back to something, putting more carbon in trees and grasses and soils back to those systems? So we can look at all sorts of things here by protecting nature and then mimicking nature on our working lands. That's how we build those carbon sinks on land. The oceans are important too. The oceans absorb CO2 3 different ways. One is by just chemically dissolving CO2 in water, basically carbonating the oceans a wee bit. We call that the solubility pump. The second way the oceans take out CO2 out of the atmosphere is by making things with shells, things made out of calcium carbonate, like oysters and mussels and clams and all sorts of delicious things. But also coral reefs. Corals are made out of carbonate too. So when they make corals and we make beds of oysters and shellfish, that's taking some of the carbon out of the atmosphere and basically making a rock out of it. That's pretty cool because it's going to stay there for a long time. The third way the oceans take up carbon is just photosynthesis, what we call the biological pump. That's going to be kelp and phytoplankton and all the little plants in the ocean doing photosynthesis. And when those plants and little critters die and they float down to the bottom of the ocean and stay there for a long time, that's a carbon sink. That's pretty cool too. We humans, though, don't have much ability to change the vast areas of the oceans so far. So the solutions there are mainly protecting nature, protecting the oceans, and let it do what it was doing really well. But maybe by farming kelp, by adding new like oyster beds, maybe new artificial coral reefs, things like this, we can not just protect the oceans, we can maybe augment it and kind of add more back. But in the near term, I think things like protecting mangroves and wetlands along their ocean shores is probably the best thing we can do, along with marine protected areas. Finally, there is a lot of talk, and that's all it is right now, about machines that could suck CO2 out of the air and lock it away forever. There are some promising kind of pilots, a few out there in Canada and a couple other places that are kind of interesting, but they're basically lab experiments, a few deployed in the field. The ones that are out in the field takes about half a ton of CO2 to absorb 1 ton of CO2. It's not really that great, and they're not that scalable yet. In the future, though, we might have more machines that can pull CO2 out of the air, for example, and bury it someplace, locking it away. That's cool if we can do that, but I wouldn't hold my breath. And second, I'm much more interested in machines that can take carbon dioxide or other gases out of the atmosphere and use it for something. Wouldn't it be cool if our cement and our plastics and jet fuels and things we might still want in the future, what if they were made not from oil, but from the air? We took pollution and recycled it into something cool and useful. That would be amazing. There's some very promising uses of what's called, it's basically carbon capture and utilization, not just carbon capture and storage. But right now, these kind of engineered sinks are at least 10 to 20, 30 years out, and we can't afford to wait for them. If they come online later, great, let's use them. But right now, they're really not doing anything, and we've got to get started now without them. They're going to catch up, but right now, we're going to have to do it alone. So we've looked at reducing the sources of pollution. We've worked with nature to remove some of it and keep removing it. A third area I haven't mentioned yet is things that weren't intended to be climate solutions, but turn out to be. And a lot of those are things we do to improve society as a whole, especially around equity and things around justice and equity and economic opportunity. For example, when women and girls get more access to healthcare and to education, remarkable things happen. So many good things happen. But one of the things that happens is girls will have children that are healthier. And they'll probably have fewer of them, maybe a little bit later in life. And that voluntarily, with no kind of draconian top-down measures, helps kind of flatten out the population curve in the future. Now, most of our emissions are caused not by population growth, but by rich people emitting way too much. But population will be later on, could be a factor, as more people on the planet who then get richer later could be adding emissions to the future. So this is kind of important too, as is helping indigenous communities secure land rights, the lands they've stewarded for millennia. What's really interesting is if you look at any forest in the world that's managed by indigenous communities, they almost always have more diversity, more productivity, and more carbon in them. That's not just in the tropics. For Americans in the audience, you can look at a map, a satellite image of Wisconsin. In the upper kind of left-hand corner, there's a dark green square of forest that's much darker and full of trees, more than all the surrounding landscape. That's the Menominee Nation. That's an indigenous folks managing their forests better than all their neighbors. And that's true almost everywhere you look in the world. So sometimes we do things not for climate change, like empowering women and girls, education access, healthcare access, helping indigenous communities secure land tenure. We don't do that for climate change. But when you do, it has a kind of domino effect that gives some benefit to climate as well. That's awesome. So when we put it together, the solutions to climate change look something like this. We've got to reduce big sources in about 5 major areas: electricity, food, industry, transport, and buildings. I've now collapsed all those little solutions into kind of big sectoral kind of clusters of shifting electricity production, energy efficiency, waste and diets. Those are what we call solution clusters. Then we have, of course, the sinks working with nature. We can do a lot on our land by protecting what's already there and shifting the practices on our working lands, agricultural lands, and those that we've already degraded. That's really important. So far, what we can do in the oceans is a little bit limited, but I think that could grow enormously. And we're actually doing a lot more research on that this year. And then the machines that may come along and remove carbon, the only thing we have now is maybe biochar. That's about it. And that's what we show here. But we need more, and that'll take time. And then the third principle of climate change are things we did anyway, not for climate change, but turned out to have a real benefit. And especially access to health and education, especially for women and girls, turns out to be a really interesting kind of climate solution too. So this is the chessboard, folks. If you want to win this game, you got to look at all these pieces, and this is what we have to do: is all of those circles simultaneously, all beginning today. That's the only way we're going to get there. And we've done the math. We've shown that when you deploy these solutions, you can change the future. Here's what CO2 levels probably would do based on our best understanding of the economy and current commitments to address climate change. The red curve basically keeps going up, and that's going to cause more and more disruptive climate warming. But we don't have to do that. We could bend the curve like this yellow one or this green one, for example. These are just two scenarios we looked at. One's pretty aggressive, scenario one. One's really aggressive. And guess what? They stop climate change. The most aggressive one we could think of stopped climate change in the mid-2040s and limits the damage quite a lot. The little less aggressive scenario can do it by the early 2060s. Everything in between is still possible too. It's not just these two scenarios, there are many, many more. And this is all with no new technology at all, nothing new, just what we have in our hands today. So if anything, this could be conservative. And what it would do is it would limit the warming. We're already at about 1.1 degrees warmer than we should be. We waited too long to deal with this, but we can, if we hit the brakes now, we can stop the warming by about 1.5 degrees and 2 degrees. That's all doable still, but only if we act now. That's the big problem, is time. But we do have enough solutions. We don't have to invent anything new, though it would be great if we did. We have enough solutions today to do the job. And yes, it'll cost a little bit of money up front. Here's what economists will call a cost curve. Basically, we stack up climate solutions from left to right, from the cheapest to the most expensive. And the cost is shown in the graph below. If it's negative, it means the minute you deployed it, you already made money. And then the others to the far right cost something up front. But what you really want to look at is not the down payment, but the long-term cost. It turns out by deploying climate solutions, way more than almost 3/4 of them will make you money. A few don't, about a quarter don't. We might have to subsidize those, but the rest make tons of money. In fact, for every dollar we'd have to spend to stop climate change, we'd make 5. That's incredible. And that's not even counting the cost climate change would cause us in the future if we don't stop it, which could be much, much, much larger, almost incalculable. So anybody who tells you it's not economical to address climate change is just lying, period. That is not true at all, and we've known that for a long time. In fact, this is the biggest business opportunity in human history, and we have to do it, and we ought to do it because it's a really good idea. It's only very inconvenient for a few industries who are very powerful, but for the global economy, the rest of us economy, it's a really good deal, and we should do it right away. So what have we learned? It is not too late at all to stop climate change from being catastrophically bad. It's still going to happen. We're already there. We've already started climate change. We can't reverse it immediately, but we can stop it from getting a lot worse, and we can do that starting today. But we have to start today. We've been diddling around the edges of this problem for 30 to 40 years. Scientists like myself and many, many others have been shouting at the politicians and all of us for 3 to 4 decades about how dreadful this is and how serious it is. And we've waited and waited and waited, and that bought no time at all. We lost time. But if we can scale what we have today, don't wait at all, we can maybe make a difference. And we always say this at Drawdown: now is better than new. The new technologies people are excited about are great. Drop them in later, but in the meantime, get started now with what we have in hand. Don't wait. Now is better than new. Time is more important than tech. So that's how we're going to move forward. But how do these solutions get into the world? That's a whole other question. What we showed you were physical solutions that actually change the nature of the air in the atmosphere, things that move the needle on the planet that get us to drawdown. To get solutions into deployment, to scale them, we've got to deploy what we call accelerators, like policy, change the rules, change laws, regulations, taxes, incentives, broadly speaking, what we call policy. That doesn't just happen at the federal level, by the way, that happens at the level of states and provinces and cities. In fact, most of the climate policy that really matters is local. It's whether or not you can put a solar panel on your roof, your building codes, who runs your local public utility commission, who decides where the buses go and whether they're serving underserved neighborhoods, who's going to vote on the bonding bill for the new train system. That's local policy. It's not as sexy, but actually most of the climate action in the world has been like that. Very boring stuff day to day that we got to do. We also have to shift capital. We're going to move trillions of dollars out of bad stuff like fossil fuels and industrial ag and things that are destroying the planet and put them into good things like renewables, regenerative ag, other things. The leading tip of that spear will be impact investors and philanthropists, people who are looking to the future for returns, for money or social impact. Those are really important. We also have to work with business so they recognize climate change is not in their interest, that the goal isn't just to make money, it's to be able to keep doing business too. And that requires sustainability, that requires addressing climate change. And we have to hold businesses more accountable for their action and have them be more visionary than just quarterly returns. So we need reform in business. We need technologies, absolutely, but don't wait for them. And we do need to change our individual behaviors too. A lot of people say it's not individual change, it's system change. I'm like, yes, we're part of that system, by the way. Systems changes don't happen at the bottom or the top, they happen everywhere. And so if we change our behavior, yes, hundreds of millions of people changing light bulbs matters. Changing what you drive matters. Food waste matters. It's not enough, but it helps make the other system changes at the policy level, the business level, the capital level, all those easier. If people are more energy efficient, it makes renewables easier. If people are using less food and less food waste, it makes more innovations in the food system easier. So don't think your actions don't matter, they do. But we need systems changes, require changes in all the parts of the system interconnected, not just at the top or just at the bottom. We need them all. So those accelerators are going to be important, and we need to deploy them now out over the next couple of decades. Things we can start with today, like in the 2020s, do stuff that's cheap, that makes money, that we can do right now without any argument. Let's get the politicians out of it and just do sensible things, like energy efficiency. You don't need UN to tell you to do energy efficiency because you're going to make money right now doing that. Same thing with food waste. Why are we throwing 40% of the world's food away, basically? We could solve half of that problem today. Can we protect rainforest? No argument. What can we do to preserve the world's remaining rainforest, which are treasures of biodiversity, but also important for climate change? Can we do that? Hell yeah. Can we deal with methane leaks, the leaks of methane out of the natural gas pipelines and the fracking and all that kind of stuff? Yes, because it's also a safety issue. We just mandate the energy sector must do that now while we later get rid of natural gas altogether. But in the meantime, please don't leak it into the air. We ought to be able to do that too. And nowadays, switching to renewables is actually really cost effective. This wasn't true in the past, but today, without any subsidies now, solar and wind make electricity far cheaper than gas or coal, way cheaper than nuclear. And so it is the best solution, whether or not you believe in climate change or care. So this is what we should do in the electricity sector right now. And these numbers are already obsolete. They're already lower, and this is only 1 year old. This is just crazy how cheap solar and wind are getting. This is good stuff. The other thing we got to do over the next maybe decade or two, starting today though, is changing infrastructure. This is going to be deep, deep infrastructure changes. Every furnace, every boiler, every hot water heater, every internal combustion engine, and every farm on the planet have to go away and be replaced with something new. That's incredible. It's going to take us decades to do all of it. but it's going to create hundreds of millions of jobs to do all the retrofitting of transportation and buildings, electricity, agriculture, all of that. And these are jobs that can't be outsourced. These are jobs that can't be done by an AI algorithm. This is going to be a great opportunity for a global middle class to get to work doing what we need to do around this planet, rebuilding everything. And then through the next 3 decades, let's drop in, when they're available, new technologies. Oh, wow, you got me an upgraded iPhone? Great, I'll take it. Whatever. I need a new hammer. This one's better? Sure. But you still use what you got when you got it. Don't wait. Just use the tools you have, and the tools will get better. But some of the tools we'll need will be things like, better ways of making cement, making steel. What do we do about plastic? Do we just, we should get rid of a lot of it, but some of it we might still want. How do we make that? How do we deal with aviation? Can we fix that? Can we make electric planes or planes that run on no carbon fuels? Yeah. So this is not just a problem we're addressing, it's the biggest opportunity in history, because while we're addressing climate change, we get to rebuild the world. We don't just have to do it, we get to. It's going to be awesome. When we're done with this, I'm so convinced we're going to look back and say, why didn't we start earlier? This is great. We've got better lives, better cities, better food, better energy systems with cleaner air, healthier people, with less disruption to the political economy and more money. What the hell are we arguing about? This is fantastic. So I want to kind of build a 21st century civilization here. Do you want to join us? That would be pretty cool. And we get to reimagine everything. It's going to be so exciting. This is not a downer at all. It's an entirely limitless opportunity to build a better world if we just deploy our creativity, our technology, our know-how, our tools, everything we can do. But one of the things we don't have, unfortunately, is enough visionary leadership. This is the part that really worries me most of all, especially in an era where we seem so divided. We need leaders who inspire us and bring us together to build a better world. A lot of the leaders we have today talk about the future as like a grim, terrible future, and those people are to blame. They say the future will suck and they're the problem. That's not leadership, that's division and bullying. Leadership says, no, a better world is over here, and we can get there if we come together and build that. Martin Luther King didn't go around America saying, I have a nightmare. He inspired us with a dream that was deeply uncomfortable to a lot of people, unfortunately, and he paid for that with his life. And we're nowhere near fulfilling his dream yet, but we're starting, and we're getting in the right direction, finally. And so I think we need the same thing with climate change. Can we inspire people with a dream of a better world and pull us together to build it, not arguing about who's to blame for the fact things are getting worse? That doesn't help. So visionary leadership is probably the most important tool in our climate toolbox, and we don't have enough of that right now. But I would like to ask all of you, since I got you on the screen here for a while, to help. Because it's not just the people we elect, the people we adore as celebrities, it's everyone in our leaders. We can all help with that. And so learn more and share more about climate solutions, not just the problem of climate change, but what can we do about it? How do we pull people together at the grassroots and the treetops so that we can solve this problem together? Because that's the only way we will. I hope we can be a little bit of a resource or a guide along the way. We won't solve climate change, but we're here to help people who will. And so drawdown.org, our social following, please follow us. We have lots and lots of resources. We're going to have a lot more. And lastly, before we hand it back to questions, is remember, the future isn't written yet. You get to do that. We get to do that. We all get to do that. So the future belongs to the people who take some risk and accept the responsibility of creating it. And that could be you and me. So with that, I'll stop here. And I apologize again for the technical glitch. I don't know if that was on our end or Zoom itself, but we're here now. And most of you stuck with us, which is awesome. So thank you very much. And I'll hand it to Dr. Bagley over here to help us with some of our questions and answers and see what's going on.
Thanks, John. Can you hear me okay? Can you hear me?
I don't hear you.
Oh, shoot. That's awkward. You know what I'm going to do? We're just going to, how about if I awkwardly call you and we'll just do this weird.
Are other people hearing you? Is it just
this
me?
Weird hybrid, everybody. We'll just try this.
You know what? I'm going to leave the conversation, come right back. Something is going wrong with my Zoom, I'm convinced. So I will come right back, Elizabeth, okay?
Okay, sounds good. So hi, everybody. I'm glad you can hear both of us. And yeah, let's give John a virtual round of applause in the chat. And thanks, everybody, for filling up the Q&A. So what I'm doing, just so you know, I should let you know, I'm copying some of the, you got me, John?
Yeah, I can hear you now.
And then there was sound. Amazing. We have sound, everybody. You're getting round of applause in the chat box, John.
No,
lots of gratitude for people. I wanted to start with, one of so many. First of all, there were over 300 people on this webinar. So thanks everybody for hanging out with us. We're going to be here for about 15 more minutes answering the incredible questions that you've been sharing with us. I'm not answering them live. I decided today what I'm going to do is I'm actually copying them and popping them into a Google Doc so I can share some with John. And what we're also thinking about is ways that we can capture some of these more long-term and put an FAQ site on our website. So if you don't get your answer today, that will be, I actually have our comms team in the Google Doc right now, getting ready to figure out the FAQ site. That's not going to be up tomorrow, everybody. So thanks for your patience. But we love hearing from you and also just getting feedback on where you still have questions. So John, just a quick comment from folks. First of all, everybody is so grateful for the presentation. So thank you. And
sorry for the
we had
glitches.
one attendee say that it's really interesting that the same metaphor with the bathtub has been used for why we need to keep COVID cases down. And there are just lots of parallels with flattening the curves and the language of the crisis. And I'm wondering if you want to talk a little bit more about kind of, COVID and climate.
Yeah, it's really interesting. There's so many weird parallels. Here are a few. We could talk about that for days. One lesson is listen to the bloody scientist, because not just with COVID, scientists who work on epidemiology, the study of diseases and public health, basically, they've been warning us about an outbreak of new novel viruses since like at least the 1980s. There's a book called The Coming Plague from Laurie Garrett, in fact, and published in the early 90s, I think, that was foreshadowing all of this stuff. And I don't work on this myself, but I have a lot of friends who do, and I've been hearing about this stuff for at least 3 decades. And in fact, coronaviruses from bats was exactly modeled by a bunch of people who worked for the Obama administration. We set up some of the best scientists in the United States, and I know in other countries as well, who were trying to be doing surveillance and preemptive kind of planning of what to do during a pandemic. And frankly, our leaders failed us magnificently badly ways by ignoring the science and then making it partisan. In this country, at least, wearing a piece of cloth over your mouth to protect you from a virus suddenly became a political statement. That's insanity. But it's very parallel to what we've seen on climate change. It became polarized by very cynical special interests and politicians who are more interested in your votes than in helping you. And that's terrible. And every horror movie of like a bad horror movie and science fiction kind of thing always starts with somebody not listening to a scientist. So listen to the scientists. They actually know a few things. Doesn't mean you have to follow all their advice, but at least listen, will you? Jeez. So that's one parallel. Another parallel is COVID is like not the whole problem. This one epidemic, we're lucky we haven't had many more, because this is like the COVID outbreak is kind of like one bad, really bad hurricane. The problem is they're going to happen more. So in climate change, a warmer planet will cause more and more destructive storms to happen. We're already seeing that. And as we deteriorate the physical part of our planet, our atmosphere, our oceans, and messing it all up, bigger and badder storms are going to happen. But over on the biology side of the planet, tearing down rainforest, bushmeat trade, eating animals we shouldn't be eating, mixing people into novel ecosystems where we've never really lived before, and then fly around the whole planet. And doing agriculture in insane ways where millions of animals literally are put into little pens right next to millions of people in some parts of the world. Those are insane. So the deterioration of our biology is unleashing storms as well. And those are called pandemics. We're going to have more of them, folks, because we've degraded the biology of the planet that kept diseases in check, kept nature a little bit away from people. We knew better, but we don't. So again, like climate changes causes storms, biological changes causes pandemics, and it's almost exactly analogous. The last thing about COVID people were asking a lot about is like, hey, did this affect climate change? Like, not really, not so much. This year's emissions of, just 1 year's emissions gone down a lot, maybe gone down 5-10%, we'll see, globally, some more in some countries. But if we rebound next year, we just bought 10% of 1 year's worth of emissions. That's not enough. And no, this is no way to stop climate change. It's like killing people. No, don't do that. I'd rather have climate change than pandemics. Okay, this is not good. But it maybe taught us a few things. Maybe as we build back the economy out of this deep recession we're in, which is the worst jobs recession since the Great Depression, maybe we can build back better. Maybe we can be smarter. We can put people back to work to fixing our climate problem and our economic issues and our social and racial equity issues that we have still. Of course, those are things we ought to do. Also, maybe we could, hey, we've learned how to video conference a lot more. Maybe the demand for office space will go down. Maybe we can be more flexible. We don't have to fly as much, which is fantastic too. So maybe the long term after the COVID kind of implications might be we'll be a little wiser, a little smarter, and do things a little better. That happened during the last recession too. The United States, for example, the highest emissions we ever saw in our country were in 2007. They went down during the Great Recession in 2008, and they kept going down as we built back the economy. And they're the lowest they've ever been this year, not just because of COVID, but they already had dropped 15%. During the Obama administrations especially, we saw the first time in American history lowering greenhouse gas emissions while the economy was growing faster than almost ever. That's kind of amazing. That's never happened before. Maybe it'll happen again as we build back a slightly better economy that maybe serves us a little better. We'll see.
Thanks, John, and thanks, folks, for making the connection between bending the curve, both with COVID and with climate. John, we've got some questions about businesses. So there are a number of people who were interested in knowing a little bit more about how are we at Project Drawdown getting businesses to shift their mindset so that they can embrace drawdown?
Yeah, it's really interesting. Businesses are kind of tripping over themselves now to kind of talk about climate change. A lot of them are taking kind of what we might call a Paris pledge. That is, let's commit to being net zero emissions by 2050 or so. The whole planet better be there by 2040 to 2050. So I don't think a leading global business said, oh, we'll be, at the end of that, we'll do that too. Is really that much to get excited about. And a little bit of that can be a shell game too. It doesn't say zeroing out our emissions. It's saying they'll be net zero, that they could still emit, but then they'll help somebody else kind of offset it. That could be a shell game if we're not careful. We got to be really careful about that, but it's a start. It's a good start. At Project Drawdown, we're trying to work with businesses to have what I think is kind of real, serious climate leadership, which is going beyond that. Full disclosure, this is a company we've worked with and actually funds us. So just so you know that, I want to be very transparent. But we've been working with a company, Intuit. They make things like TurboTax and QuickBooks. So basically make accounting software for the world. Pretty interesting stuff. A couple of years ago, I started talking to them. They've been working with Drawdown for a while, and they were telling us, hey, we can get to net zero pretty soon, actually, by 2021, 2022, 2023. That's great. And we kept talking to them like, wow, it's fantastic. You're faster than anybody in the world. That's great. And then we talked, and they got the idea of like, why don't we keep going? Because it isn't just the company's footprint. They could work with all their customers and all their suppliers, their employees, and help them too. So a company like Intuit, they have 100 million small business customers, let's say. I don't know how many it is. It's about that. And if Intuit can get them to reduce their emissions just a little bit, it's way more important than what they did in their office buildings and in their servers and stuff. So the idea of going beyond carbon neutral into being way bigger than that. So that one company committed to going 50 times beyond carbon neutral and doing it by 2030. That's the boldest climate leadership I've ever seen. Microsoft saying they're not going to just be carbon neutral. They're going to erase all of their historic emissions they've ever done since Bill Gates was in a garage. That's incredible. Google's doing a lot. So tech companies are starting with this, but we need everybody, not just a few kind of leading tech companies. We need a lot of businesses to say, hey, it isn't just our little operational footprint, which is hard enough. It's also what we do in serving the world. It's the tools and services we provide, our social capital, our political power. I'd like to see the CEOs of these companies lobby in Congress and the White House and others around the world to say, hey, you got to step up on climate change. And I haven't seen much of that at all. So companies can do a lot more than they have, but we're seeing some changes, but let's keep pushing. We need activists to kind of raise hell and make companies like get a little scared. And we need kind of pragmatic partners say, okay, and here's how we can solve the problem together. And I think we're beginning to see that. But gosh, I wish it happened a little earlier. We need all the help we can get.
Thanks, John. Thanks for bringing that up. We've had a couple of questions about, how Project Drawdown is funded and how people can help. So I'm wondering if you can shed some light on that, please.
Yeah, thanks for asking that. Project Drawdown is primarily funded by individuals. We're a charity. We're a 501c3 in the United States, which is a public nonprofit. We don't get any government funding. We don't have any sort of, business side, and we don't charge for our services. We give everything away for free. We're a public benefit nonprofit, and we're very serious about that. So we critically depend on donations. A very large fraction of them come from just regular folks and some fairly wealthy families and others who are very generous to climate solutions. That's really helpful to us, of course. We also have some donors from big foundations, and we have some from corporate foundations, but we disclose all of them. We never, ever take money from fossil fuel companies. Absolutely not. Will not ever do that, never have. And we will never accept funding from individuals, foundations, companies, whoever participate in major climate denial. They're dead to us. I won't accept their money, period. But we do need help. And if we can do a little plug, we have a challenge grant or two going on right now. Dollar for dollar will be matched for contributions on the internet up to $25,000 right now. And then we have another donor who's going to match up to $400,000, some larger gifts. If anybody's interested, we love that. You can go to drawdown.org, and right at the top, there's a little button that says donate. No pressure. We give these seminars away for free. You don't have to pay a thing. But if you want to help us keep doing that and being a trusted, science-based, hopefully clear source for climate solutions that's nonpartisan and non-commercial, that we can be independent, we do need public support from individuals, but we leave it up to you.
Thanks, John, and thanks for asking that. Thanks for asking all the questions. And as I said, unfortunately, we're not going to be able to get to all of them, but thank you for having them come floating in. John, there are some questions coming through about engineered solutions. And I'm wondering if you can talk a little bit more about kind of your thoughts about geoengineering as a complementary strategy and just what we know about engineered solutions.
Yeah. So just for everybody to kind of catch up, I bet the questions are coming from folks who know a lot about this, but for just make sure we're all on the same page. We hear about ways to engineer solutions to climate change, and sometimes that's called geoengineering. That's kind of a broad term people throw around. There are two kind of big buckets of solutions in the geoengineering space. One I mentioned already, which was, hey, what if we could build machines that pull pollution out of the sky and get rid of it, bury it, or turn it into something useful like a building block or fuels or plastics or whatever, I don't know. So that's kind of carbon capture and utilization, carbon capture and storage, basically sucking pollution out of the sky, direct air capture, it's often called. Another family of solutions in geoengineering is, I think, dangerous, really bad idea. It's saying, well, if the planet is warming, maybe we could do, and we do that stuff because of us, maybe we could do something in addition to that to cool the planet by the same amount by, I don't know, sprinkling stuff in the atmosphere like aerosols in the upper atmosphere to reflect some sunlight. Or maybe we could put, big mirrors in space to reflect the sun's radiation away and cool the planet the same way. That's insane, I think. I really think this is reckless and not a good idea. My opinion only. I'm not speaking for others in this case. The reason why is because the physics of how the planet warms from greenhouse gases is that it traps heat mostly at nighttime, mostly in the colder seasons, and much more so in the polar latitudes. That's where the warming is happening the fastest, the North and South Poles, basically at night and in the shoulder and colder seasons. Reflecting sunlight back to the sun away from the Earth to cool the planet on average will do it during the daytime, during the summer most of all, and most of all in the tropics. It would be like if you had a 3rd-degree burn on your feet and you stuck your head in ice water and said, well, on average, you're fine. Don't worry about it. Like, no, you're causing one problem to counteract another problem. Why don't we just solve the problem over here? And we don't need mirrors in space and flying around in jets throwing out aerosols. I just showed you all the solutions to climate change are far simpler than this, far less dangerous, would make us money, and are just damn good ideas, and we don't need to worry about that. There might be engineered solutions at the local level, how to keep like a particular glacier from melting and causing havoc. Maybe you could do something there. Maybe we can do some things at the local level. I get that. Like local engineering is called design. I like that. Engineering our way out of the solution by ignoring the original problem, I think is just kind of more bad thinking that got us in this mess in the first place. But that's just me. Others will disagree. But that's my take on it. But the physics of it is really wacky. You don't cool the planet in one place to counteract warming in another. It would mess up weather systems and seasons and things like you wouldn't believe. So I think that's a really not so great solution, but it deserves more merit study and analysis. So I'll say that. If scientists can figure out a way to do it that wouldn't be harmful, then maybe we should look at it. But right now, I just don't see it.
Thanks, John. So we've got time for one more question, and there have been some questions coming in. A number of people first learned about Project Drawdown when the book Drawdown came out in 2017. And so I'm wondering if you could talk a little bit about, is Project Drawdown, oh, John's getting a book, everybody, we've got a show and tell coming. Here we go, show and tell. If you could talk about kind of what's next with Project Drawdown, how are we going to reach the world? What are some of the ways that we're going to communicate and connect with people?
Yeah. Well, I'm so glad that people learned about Drawdown. A lot of people learned about Drawdown from a book we published back in 2017. Drawdown was a book project. That's why it was called Project Drawdown. And they published one book that became a New York Times bestseller. It was the first time people really synthesized climate solutions and showed, hey, there's hope. We can maybe solve this. It's beautifully written, beautifully put together, and beautifully researched. So that was a very good thing. But in 2018 or so is when I came on board and was asked to kind of reboot the organization a little bit and take us to the next level, saying, well, we're not just a book project. We should be a world-leading resource in multiple ways for climate solutions. And now we're kind of like a larger nonprofit trying to do more than one thing. So we are going to focus a lot more on digital communication. Books are great, but they're expensive. And they're, a best-selling climate book still only sells a few 100,000 copies. So we've actually updated the entire book, all of the research and everything. And instead of publishing another book you'd have to buy somewhere, we're giving it away for free. And we're going to keep updating it. The first of what we call the Drawdown Review is available for free on our website. Just download it to your computer, print it out if you want to. But it's free. You don't have to charge for it at all. You can give it away. We don't care. And it's the latest research. This is a 2020 book. The 2017 book is still being sold in bookstores, but this one we're giving away for free. Go get both. They're great. We also just launched what we're calling a series of Drawdown primers. The very first one just came out, a couple of weeks ago on agriculture and climate solutions, especially around regenerative agriculture. It's getting a lot of questions and kind of, discussion lately. So we wrote a whole kind of deep dive on that. We're going to be ramping up both of these efforts. And we just brought on some excellent new communications team members and others will be doing that. We're also going to be doing a lot more kind of videos, including classes that Elizabeth mentioned. So in a couple of weeks, hopefully in January sometime, we'll have the Climate Solutions 101 series of videos, which will include at least 16 videos from different people around the world, going through a lot of what I did in just 45 minutes or so today. And it'll be a really great resource, we hope. And we're also going to be doing a lot more like storytelling, kind of not just the analysis of climate solutions, but the more human stories of the people doing them in the world, to go a little bit, not just the head and heart in that order, but how about the heart, then the head. So stories combined with great scientific information, hopefully presented really clearly. We also started producing new materials, like we have this fancy dancy new set of posters. We're going to make these available on the web, so you can download a digital version or go print one yourself and just pay for your own shipping and it'll get to you, no problem. And we're going to have lots more resources. So I'm really excited. We're now building Drawdown 2.0. We're a little behind where I'd like to be because of the pandemic. Everything slowed down a little bit, but we're roaring ahead on a lot of good new fronts with Drawdown Learn, Drawdown Labs, where we work with businesses and philanthropy and investors. And later, I'll tell you, well, we're launching a new project called Drawdown Lift, which is looking at how climate solutions can also help people who are struggling around the world and vice versa. That is, how can people lift themselves out of poverty, out of unhealthy conditions, out of injustice, while drawing carbon down? How can we have a win-win solution to climate change, but also to improving human well-being? And we'll be launching that starting in January. So lots of exciting new stuff at Project Drawdown. It'll be way more than just the original book, but that was the foundation. That was our charter to get started, essentially. And we're moving on from there.
Well, thank you so much, John. Another kind of virtual round of applause for sharing all of your expertise and wisdom with us today. And thanks to the over 300 of you who took time out of your days to learn about climate solutions. And our ask of you is to keep talking about them and start putting them into place in your homes, in your communities, your businesses, all around the world, because we need all of you. We need all of you to step up and start putting those climate solutions into place so that we can reach that moment in time, the moment of drawdown. We hope all of you have a fabulous holiday season. Thank you so much again, and be well. Thanks, everybody.